Okay, so in this problem, we're given two inequalities, and we're trying to find the graph that best represents the solution to both, right? The common solutions they have. So I'm going to zoom out so you can see this. Pause the video, try it on your own, and then see how we do it in the video and compare. Okay, so let me zoom back in. In this problem, we're given two inequalities, right? So we're given these two inequalities, and we've got graphs of them. What I first do is write them in mx plus b format. It tends to help me in these problems. You don't have to do it this way. It seems to be really helpful. So what I mean is I isolate y. So in the first one, right, in this problem right here, all we have to do is subtract x from both sides, and we've got y by itself. So y is still greater than minus x from both sides, so it's 2 minus x. Y is greater than 2 minus x. And in this problem, we already have y is less than or equal to 3x minus 2. So the way I think about this problem is, at first I think, well, what if y was equal to 2 minus x? What would that look like? And what if y was equal to 3x minus 2? What would that actually look like? Well, these lines that they're giving us in each of the choices show what that would look like. Look at the first example. 3x minus 2, this red equation right here, is represented by this line. And we could tell that because our intercept is negative 2. Remember this term over here by itself is called the b term. It's the y-intercept, and that's what our y-intercept is here on the y-axis. And the slope is 3. We go up 1, 2, 3, and over 1. So our slope is 3 in this line. So if y was equal to 3x minus 2, this line, this red line, represents it. If y was equal to 2 minus x, this would be the line that represents it, right here. Oops, let me choose blue so it matches, don't want to confuse you. So if y was equal to 2 minus x, this would be the line that represents it. And we know because 2 is our b value, the number all by itself, the constant, and the slope is minus 1, down 1 over 1, down 1 over 1. So if they were equal, these blue and red lines represent these blue and red equations, but we don't have them equal. In the blue equation, y is not equal to 2 minus x, is greater than 2 minus x. So that means that it represents everything above the blue line, not including the blue line. So this, when they draw the solid line, that means solution sets include the line. And since this is greater than the line, not greater than or equal to it, this can't be the answer. So we know this line, this blue line, needs to be dashed, not solid. So we eliminate choices 1 and 3. And then out of the two remaining choices, we know the answer now has to be 2. How do we know that? Well, look at this blue line, this dashed line right here. Right? Notice how they dashed it and then shaded above it. So they're saying that this region that's above the line, 2 minus x, y is greater than that. All the y values or heights greater than the line 2 minus x is our solution set for that inequality. And the other one, the inequality, is that y is less than or equal to negative 2 plus 3x, or 3x plus negative 2. And that's this red line right here. It's a solid line. And y is on the line. It could be equal to it, less than or equal to, or anything below it. And the common region is the region where these two shaded areas crisscross. I didn't do the best job shading, but notice you want to try to shade perpendicular to the line so you can see this crossing pattern. Now you don't need to do this last part, but I like to color this in so to emphasize that what I'm talking about is this solution set in here. Any point here in this yellow area or on this red line here, not on the dashed line above that, is a common point that works for both inequalities. And you could try it. Try a point, anything in this yellow region. I'll unshade that so you can see. Take any point, plug into both inequalities, and it works. So for example, the point 1, 2, 3, 1, this point right here, 3, 1, if you plug in 3 for x into either inequality, then it's true. So if 3 is x, you plug it in here. 3 times 3 is 9, plus negative 2 is 7, and 7 is greater than or equal to 1, the y value. It's also true here. It's a common solution for both. 1 is greater than, right, 2 minus 3x. So 2 minus 3 is negative 1, that's less than y, so it works for both. So again, this is a harder problem. I would stop the video, start it over, and try it on your own if you want to practice it. Thank you.